So it is time to take a look at the last lesson of Unit 2 before we have a test. So in Unit 2, we're starting in lessons 1, 2, 3, and 4. We're dealing with percentages and how we can't use a percentage inside of a math problem. So we have to be able to change our percentages into fractions or decimals. Now in Lesson 4, we were finding the percent of a whole number, where in this lesson, we're going to go in reverse. We're actually going to be finding the whole number when given a percent and part of a number. So as usual, when we get into a math lesson, I try to fill in some gaps that it seems apparent that we are missing, or things that commonly sixth graders come to me not knowing. The first thing we're going to do is we're going to look at the lesson objective, and that once again is the I can statement. I can find the whole given the part and the percent. So I'm going to find a whole number if I know what a percentage is and a part of what that is. And there are three things I need to keep in mind. So the way I'm going to teach this, because it really is much easier, is to always change my percent into a decimal. Could I do the math problems by changing it into a fraction? Yes. There are just more steps and it becomes more complicated. So I'm going to teach it and show all my examples of changing my percent into a decimal. The second thing I want us to recognize, and that's going to also be in our packet, is you should have already highlighted, I believe it's on the third page of our reference packet, that of means multiplication. 85 to 89% of the time that of is in a math word problem, it means that we're going to be multiplying. Now, in some of these, we're going to have to add it as we're reading the problem so that we know that we're starting with multiplication. But that just means you need to pay attention as we work through some of these. And then the third thing is that we want to mark in our packet the word is means equals to. So we know that if something is this, then that's what it's going to be equal to, and that's going to help us set up the problem. So what I'm looking at in this first example, where it says learn to find the whole, we're given that we have 60% of some number, and that is equal to 114. So when I set those up, then my first step is I know I have to change my percent into a decimal. And we do that once again. If you don't know this, then please start making notes so you get this in your mind, because this is a process that you need to understand. We drop the percent sign. If there's not a decimal, then I'm going to add the decimal. And I'm going to move that decimal from right to left 2 times. Now, if there is already a decimal, then I just simply move it from right to left 2 times. But that's going to give me 0.60. We know that of means multiplication, and that is means equals to. So the math problem that we're going to work, instead of dealing with 0.60, the 0 doesn't change the number at all. And I know that I'm going to have to be shifting decimals, and I don't want to have to do it more than I need to. So I'm just going to drop that extra 0 off and just use 0.6 or 6/10. So I have 6/10 times something is equal to 114. So now what do I do? Well, that's going to be the fourth step. And the fourth step is that I'm going to change it into a division problem, where I'm going to end up finding the whole value for the math problem. So if you go to Canvas and you look at your announcements, you'll see this image. I've added, my little emoji, but these are the 4 steps that we're going to follow every single time. But how do I know how to set it up? Because I don't know what that question mark is. That's algebra. Do I know how to do algebra? So do I know how to find a missing number? I mean, that's algebra, right? So if I think about working with numbers, I've actually been doing this for several years, as I said. So if I look at the math problem of 2 times 3 equals 6, we learned that in the end of 2nd grade and all of 3rd grade, we worked with multiplication. And you probably know that if you just simply rearrange the 3 and the 2, you get a second multiplication problem still equal to 6. So when I look at those, I have the same 3 numbers, and I've created 2 multiplication problems. But I can also use those same 3 numbers and create 2 more problems. They're just the opposite of multiplication. They're division. So if I take the answer of 6 and I move that to the front of the math problem, I can actually divide it by one of the smaller numbers. So if I take 6 divided by 2, that's equal to 3. Well, then if I switch the 2 and 3 again, and I keep the 6 in front, I can take 6 divided by 3, and that's going to be equal to 2. So notice I have the same 3 numbers, 2, 3, and 6. I've created 2 multiplication problems and 2 division problems, 2 and 2. That is a multiplication and division fact family. In the same way, I can do the same with addition and subtraction. If I know that 4 plus 5 is equal to 9, and I switch those two smaller numbers, the first two, just like I did in multiplication, I can create a new addition problem and have 5 plus 4 is equal to 9. And then I do the opposite. I'm going to subtract. So I'm going to take the answer once again and put it out front. And I'm going to take 9 minus 4 is equal to 5. And then if I switch the 4 and 5 again, keep the 9 out front, then I can have 9 minus 5 is equal to 4. So I end up with 4 math problems, 2 addition and 2 subtraction. That's an addition and subtraction fact family. Fact families is the best way to think about math when I have a missing piece in order to solve for the missing piece. And once again, that's just algebra, and you've been doing that for years. So if I'm looking at this idea of this math problem, and I know I have 0.6 or 6/10 times something is equal to 114, and I focus it on the center aspect of the multiplication and division fact families, I can see when I have my answer in that example of 6, it goes in front. In the same way on this one, the 114, it's going to go in front. And then I'm going to divide it by the one number that I have in the multiplication problem. So I'm going to have 114. I'm going to make a division problem. The only number that I have is 6/10. So that's going to go behind it. So I'm going to have 114 divided by 6/10, and that's simply going to be equal to whatever I'm missing, and that's my question mark. So I can set that up in a division problem then. But we need to review what we do when it comes to a division problem. How do we know where they go? So when we look at a division problem, this is called a number sentence. Notice it goes from left to right. So if it's a number sentence that is a division problem, the first number always goes inside the box. Now, the way we learned it in the first unit is when we talked about divisions, we talked about what we have. We have 114. And we know we're going to put it into equal groups of 6/10, 0.6. So what I have goes inside my division box, where my groupings, my smaller portions, is going to go on the outside. So if I have 114 and I'm going to put it into 6/10 groupings, then I know where they go on the division box. Another way to look at it, if that gets you confused, is just think about what it is saying. What are the words when I say that number sentence? Well, the words are 114 divided by 6/10. When I look at that and I think about how to create that, I have 114. I know that's going to go inside the box because that's what I have. When I say divided by, notice that's 2 words. There are 2 lines that I create. The divided is going to be the top line of my division problem. And then the by is going to be my side line, right? And what I'm going to divide by is going to be my last number in the sentence. Therefore, it's going to be on the outside. So when I say 114 divided by 6/10, I put the 114 inside of the division box that says divided by, and therefore the 6/10 is what goes outside. So all of those to say I need to set this up. But the other aspect that I also need you to know, and if you don't know these terms, I advise you to write them down because I know they're going to be on your standardized tests come the end of the year. We need to know what these terms actually are when it comes to a division problem. These were on your NWEA, and there were several 6th graders in both classes that missed these. So the number inside the division box is a dividend. And the way that I try to teach it is the way that I learned it when I was a kid because it was the only way my brain would remember the name of these. If I look at a dividend, the EN makes the IN sound, it's N. So if it sounds like N, it's inside the division box. Where on the outside, I have a divisor. Notice the O at the end of the word. The O stands for outside. So my divisor is on the outside of the division box. Dividend, inside. Divisor, outside. But then I have my answer, right? So my answer is my quotient. Well, how can I remember quotient? Well, if I remember, it's the answer to my question. Question starts with a QU, just like my quotient starts with a QU. So once I know what all those parts are, then I also know how to set up my math problem. What I have is going to be my dividend. If it's in a number sentence, it's my first number that is my dividend inside the box. My groupings, what's on the outside, is my second number. It is my divisor. And then I know that what I'm trying to solve for, the answer to my question, is going to be my quotient. Once I have the math problem set up, then I simply have to ask myself, can I divide a decimal into a whole number? No way, no how. It is impossible. Not a never. You cannot divide by a decimal. Therefore, we have to change it to where we can. I cannot divide by a decimal, so I have to go through the process that we refer to as OOU. I'm going to go over, and then up. So I know I'm going to move a decimal over on the outside. Therefore, I'm going to move a decimal over on the inside. Notice I'm always going to move it from left to right. And then I'm going to move the decimal up. So how many times do I move it? Well, it depends on how many decimal spaces there are in the divisor on the outside of the division box. That's where I cannot have a decimal. And when I'm looking at it, I can see there's one decimal position. So if my divisor has one decimal position, I have to move it from left to right one time. Therefore, I have to go over on the inside as well. Now, don't make the same mistake that many sixth graders do at the beginning of the year. They put the decimal in front of the 114 and they move it to the right and they end up with 1.14. No way, no how. Decimals always go at the end of whole numbers. And since there isn't one, I have to add one. Because if I go over on the outside, I know I have to go over on the inside. So where my dividend is, if there isn't a decimal, then I have to add a decimal, right? Don't get confused and shut down and say, well, there isn't a decimal, so I can't do the math problem. Well, that's not true. I can just simply add the decimal, raise it up, or excuse me, and add a zero in order to raise it up because that's my last step. Once I move it over on the outside, I move it over on the inside, I add that zero, then I can do my up, which tells me to go straight up. Don't go up to the left, don't go up to the right, go straight up so that as you're dividing, all of your answers go in the correct spot in the quotient. Once you begin dividing, then you're just simply going to ask, how many times will 6 go into, and then you go digit by digit. Will 6 go into the 1? It will not. So how many times will 6 go into 1? 0. I don't need that 0, so I'm going to go to 11. Will 6 go into 11? Sure will, one time. And then once again, I show the multiplication sign so I can remember that I'm multiplying 1 times 6 to get what I'm subtracting with. If I have 11 minus 6, then I have 5 left over. So when I borrow and I have 5 left over, I now bring down my next number. My next number is a 4. Will 6 go into 54? Yes, it will. How many times? 9 times. Now, if you don't know that, you simply pick up your handy dandy calculator and you take 54 divided by 6 equals, and you're going to see it's 9. So 9 times 6 is 54. You have nothing left over, so you're going to bring down a 0. Now I have a 0 to still bring down. Now, as we learned in the first unit, if you didn't write it down, then I'm hoping you will now, because anytime I bring something down, I have to raise something up, right? If I brought down that 0, I have to raise a 0 so it holds that place value, because the answer cannot be 19. It has to be 190. So what we're finding, going all the way back to that first page question, it was 60% of what number is 114? Well, what we're finding is that 60% of 190 is 114. So 190 is our final answer for that question. So as I'm looking at where my numbers go and how I go through the process, if I will simply go through and substitute in steps 1, 2, and 3, then I can create the correct decimal or division problem by rearranging where they go and putting them in the correct order. I put them in the correct order, then I know that I have 114. I'm going to change multiplication to division, and I'm going to be dividing by 6/10 to be equal to my missing value. All right, so let's try some practice ones. Now, just so you know, I am going to give you these division steps on a handout so that you see them, because I do have some students that are struggling as to remembering exactly the steps of division, but I think you'll be okay as we move on. If you do have questions, then please don't hesitate to ask me. Now, when it comes to the book, it says that 60% of what number is 114. They're like, well, you can try it this way, or you can try it this way, or you can try it this way. They show you using a bar diagram, which is a lot of boxes to end up drawing and figuring out what the answer is. If you end up with really big numbers, then it becomes even more difficult to draw all of those boxes. They'll talk about, hey, if you want, you could always use, the double bar graph, or you can use equivalent ratio tables. So they give you several different examples, noticing that we get the same answer every single time. But what I'm showing you is a process that you'll be able to use from now until the end of the year that will always be the correct steps mathematically. It is a sound mathematical procedure if you'll simply learn it and apply it. So as we work through this next question, let's make sure that we follow the processes, but let's also look at a process in which we can make sure we're using the correct information that we need from the problem. So last year, I was introduced to the concept of cubing a math problem. Mrs. Bloss and I worked on using that quite often with Mrs. Gallagher in our math class, and I know that she carried that over in for some of the fifth grade students as well. So hopefully some of you have been exposed to this, but it really is a quick and easy way of taking some specific steps in order to find the important information in a math problem, and then ignoring all the other things that are not necessary. So the first thing we do is we circle the numbers and the units that are in the math problem. And in this particular one, when we read it, it says, in the first year of ownership, a new car lost 20% of its value. That's 20%. So that is one of our numbers and units that we're going to use. If the car lost, well, there's another number in value, $4,200 of its value. How much did the car originally cost? So once we have found the numbers and units, then we look to underline the question that we're being asked, and that's the original price of the vehicle. Then we look for our clue words. And once again, going back to that introduction, then we're looking for of, we're looking for is, we're looking for words that can be translated into math functions. So when we look at this word of, then we know that that means, once again, to multiply. Of what? Well, of its value. Do we know what its value is? No. So we represent that with a question mark because we know that's our missing piece in our math problem. We know that that's going to be starting out as 20%, but as we look at step one, we're not going to use 20%. So we're going to drop that percent sign. We're going to move the decimal point from right to left 2 times, and that's going to give us 0.20 to use in our math problem. But once again, as we have 0.20, then we want to make it easier on ourselves, and we are going to want to change that. But once we get the math problem set up, so I have 0.20 of, once again, tells me that I'm going to multiply of what? Well, the value, and we don't know what the value is, so we just put in a question mark, and we know that that's equal to, or that overall value is going to be $4,200. Once we have that, then we think about our fact families and how I can change this around to make it a proper math question that I can answer. In other words, we want to get the question mark on the outside of the equal sign. So as we're working through it, I see that I have my original cost of $4,200. That's going to be moved to the far left. And then we're going to change from multiplication into division because step 4 tells us that we're going to change to a division problem. 20%, instead of using 0.20, we're going to just change it and make it easier to where I just have one decimal position of 0.2. And then all of that's going to be equal to some value that I have to find. So mathematically, now I'm just left with division, which we can do because we know that what I have is going to go inside my division box. So we're going to put my division box, because this sentence says 4,200 divided by 2/10. So we're going to put 4,200 inside the division box, which says divided by, and the 2/10 is my divisor on the outside. Once we have that, then we look at our thoughts and processes about, can I divide by a decimal? No, I can't. I never can. So I have to go through the OOU and change it into a math problem that I can do. So if I move it on the outside to make it a whole number, right? So I'm going to move it one time, which tells me then I have to move it on the inside. So if I move it once on the outside, then I look at where it is on the inside. And if there isn't one, I simply put it once again at the end of the number. Don't get in a hurry and put it in the front, because then that messes up your final answer completely. So I'm going to put it on the inside at the end of 4,200. I'm going to move it to the right one time because that's what I did on the outside. I fill in with a 0, so I have a holder of that place value, and then I bring the decimal straight up. So O on the outside, O on the inside, U, I bring it straight up so I know where it belongs. And then all I have to do is divide. Will 2 go into 4? Sure will. How many times? Well, 2 will go into 4 2 times, because 2 times 4 is indeed, or excuse me, 2 times 2 is indeed 4. When I subtract those, I have a 0 remainder. I bring down my 2. 2 goes into 2 how many times? 1 time, because 1 times 2 is 2. Now I'm left with a 0 remainder again, and I can't just say, well, then the final answer is $21, because that doesn't make any sense. Once again, I have zeros to bring down, and anytime I'm bringing down something, I have to put something up. 2 will go into 0 times. Bring down my next one. 2 will go into 0 times. I bring down my next one. 2 will go into 0 times. Then we have our decimal at the end of the number, and as we're looking at it, I don't have anything to bring down, so I know that I can just drop that decimal off. So what I'm seeing is that my final answer, when I am asking what 20% of what number is $4,200, then I know that 20% of 21,000 what? Dollars, right? $21,000 is $4,200. Are we getting it? So I want to work through one more with you before I ask you to do one on your own. Once again, I want to cube my question. This one is a little different because I'm missing some of the key information, so I want to show you how to make it to where it has all the information that I need. The first thing I'm going to do is I'm going to circle all of the numbers and units that I have. And in this particular problem, I have $15 and I have 30%. So once I have circled those, then I'm looking for the question that I'm being asked to solve. I underline it. Well, I'm being asked what the original price of the sweater is. Then I'm looking for my clue words, and we've been looking for of and is, but that's not there. So then I have to stop and think and ask myself, well, if Marissa saved $15 because she bought a sweater that was on sale for 30% off, then we want to know, well, what that 30% off of what? What was it off of? Right? So if I know that that's 30% off of what, then that's where I can show, oh, I'm adding the of to the problem so I can ask the proper questions, which tells me that's what I'm multiplying by, but I don't know what that original price is. So that's my missing value. As I'm doing it, then I set up my original problem, and I know that I'm going to have that 30% needs to be changed into a decimal, right? Going down to the bottom right, looking at those steps once again. So 30% changed into a decimal. I'm going to drop my percent sign. I'm going to move my decimal from right to left 2 times, and I'm going to create a decimal of 0.30 to start. Right? We don't want to use 2 decimal positions unless I have to. So once I know that I have 0.30 and we have times, right, because we have of what? Well, we're not really sure, so that's our question mark. And that's all going to be equal to $15. Then I have to remember, all right, so going back to algebra, that's my basic math fact families. So I'm going to do some rearranging, and I always take the equals value and put it out in front. So I'm going to start with $15, and instead of multiplying, I know I'm going to divide because that's what step 4 tells me. And then instead of using 0.30, we're just going to make that 0.3 because that's easier to work with. The 0, once again, doesn't change the value of my decimal, so I'm good with that. And then that's all going to be equal to my missing value, the whole that we're trying to use. So then when I have that, I set up my division problem. Once again, the first number goes inside my division box because that's what I have. And I'm going to divide 15 by 3/10. I can't do the math, right? I can't divide by a decimal. So I have to do my OOU. I'm going to move it on the outside as many times as I need to make it a whole number. I simply, on this one, need to shift it one time to the right. And therefore, I'm going to do the same thing on the inside. So my O on the outside, my O on the inside. I put the decimal point at the end of the 15, and then I shift it one time to the right. Need to hold that place value with a 0. And then my final step, OOU, now I'm going to bring it straight up. Once it's in where the position that it needs to be, then I just do my division. Will 3 go into 1? No. Will 3 go into 15? Yes. How many times? Once again, if you don't know how many times, then all you have to do is pick up your handy dandy calculator, type in 15 divided by 3, and that tells you that it's 5. Because 5 times 3 is indeed 15. When I look at my remainder, I have 0, but I still have that 0 to bring down. So when I bring down that 0, once again, I have to have something that goes up. So 3 will go into 0 times. So what we're seeing is that we have an answer of 50. 50 what? Well, when we're looking at our original question, once again, we're being asked that what $15 is for the percentage of a certain amount, right? So 30% of what number is $15. So we know that 30% of $50 is indeed $15. So that's my final answer. All right, so now I want you to try this one on your own and see how you do. Pause the video, work through the process, and then come back and check with me. So let's see if you got started correctly. Right? So hopefully you thought, okay, we need to cube this. And it doesn't matter that the name is Kai because that does confuse some people. And none of that matters. What I know is that I have 15% in the math problem. And I have 75 minutes that we're using in the math problem. And then I'm looking for the question I'm answering. And my question is, well, how many minutes long is the school day? So we're looking for an answer in a total of number of minutes to equal the school day. So if I start out by looking at the information that I have, I look for those keywords then. Once again, I have 15% of tells me to multiply of what? Well, whatever the amount of time is in the school day. All right, so I don't know how much time that is yet, so I know that that's going to be my missing value that I'm trying to solve for. Then I set up my problem and I start with 15%, which once again, we cannot use because step 1 tells me to change it to a decimal. So I'm going to drop the percent sign. I'm going to move my decimal from right to left 2 different times until I get an answer of 0.15. Now, 1500ths is not one of those where I can drop off the last digit because there is a 5 in that second position, not a 0. So I'm going to have to use 1500ths in my actual math problem. So I set it up. I have 1500ths. I know I'm multiplying. What am I multiplying by? I don't know. That's the amount of time in the school day, right? So hopefully you got that. And then you put equals to 75. So did you get that far so far? All right, so then hopefully you rearranged it, thinking about your fact families. You know the answer, the outside of the equal sign, has to be moved out in front. And then I'm going to change multiplication to division and divide by the one piece that I'm given, which is the 1500ths. Then all of that's going to be equal to my missing value. Are you good from that point? If not, then go ahead and change it and make sure that you are correct, and then see if you can do the math correctly. So then go ahead and pause the video and check with me once you get it done. If you've already gotten it done, then let's move ahead and see how you did. So hopefully you had a division box and you know that you have 75. That's going to be your dividend. That's inside your division box. You have 1500ths. That's what you're going to divide by, so that's your divisor. It goes on the outside. Now on the OOU, this is the first time that we have to go more than one time, because I have to make the outside number a whole number. So I have to shift it from left to right 2 times to make it 15. Therefore, I put my decimal on the inside at the end of my numbers, and if I shift it twice on the outside, I have to shift it twice on the inside. And if I shift it twice on the inside, then that means that I have to add 2 zeros. Once I add my 2 zeros, then I know I can bring my decimal straight up, and then I can divide. I know that 75 divided by 15 equals 5 if I use my handy-dandy calculator, and maybe you already know that math, because 5 times 15 is indeed 75. Once I get 75 as my answer, then I subtract it, I have a 0 remainder. Well, now I have 2 zeros to bring down, and if I have 2 zeros to bring down, then once again, that means I have 2 zeros to bring up. So as I do the math and I make sure that I use all of my digits, I end up with an even number of 500. 500 what? Because what we're saying is that I know 15% of what number is 75? Well, 15% of 500 is 75. But go back to the question that we underlined, in this case it's in pink, and look for the label that we're being asked to use. 500 minutes. So does it make sense to use minutes when we're talking about time? Well, only if it tells me to, right? I could change it into hours and minutes by dividing by 60, but I definitely don't want to put hours as my label, because it wouldn't make any sense that a school day is going to be 500 hours. Right? So we want to go back and always check the question and make sure we have the correct label. That's the final answer. All right, so do we understand what we're doing and how this process works? I hope so. So I spent a lot of time going through all of these steps and going in detail, reviewing several different things. So this is just a note day. It'll take up probably all of the class time to take the notes. So then the next class day, I'll give you to do the assignment.